Alright, howdy folks, and welcome to Alwa's NES Awakening. We are porting Alwa's Awakening to the NES. This is stream number 5. No, it's not. It's stream number 6. My name is Paul. I go by InfiniteNesLives online. Last time, we converted the output of tiled to the Lua output to create the name table in binary uncompressed format that works for the NES. We had an issue where for some reason my build was not working, and nothing changed except for my computer. And so this is weird, but so I built this ROM on a different computer, the one that I had been using previously, and this one works. I don't know why when I put it on screen, the sprites don't move. But if I put it on my secondary display, it works. That's weird. But it's working because my sound effects work. Okay. Let's open with Messen instead and see what happens. Okay. So Messen doesn't have a problem in the other screen. I wonder if it's really just this problem with the display. All right, so let's go ahead and just try to make this again. But it seemed like for some reason it wasn't building on this machine, but it built fine on other machines, and it wasn't booting before last stream, and we had it in. I was only opening FCUX. I didn't bother with Messen. But it appeared that it was working in so if I take it off screen, it updates. So I guess the issue may very well just be that FCUX on this computer, I guess, I don't know, does not like being on the secondary display. Okay, so I think we figured that out. I don't know why, but I don't really care. Okay, so this build we had the output from NES Screen Tool to create the name table and everything. But now we have things set up with tiled, so we can create screens here, and then create them in here and then bring them so we export from Lua, and then we created a binary file. So I'm trying to remember how we did this. I think this is the file that we created. Yeah. It's only the name table data. It's not the attribute table data. So I stole the heads up display from NES screen tool and appended it in here. So, or prepended. Anyway, let's what was the create? Okay. All right, so we just rebuilt it. That's working. So now we have this tiled name table. Let's copy this into projects here. Maybe I'll open a window you guys can see. Why is this? So I didn't hear anything for off. In the beginning I wasn't actually talking. So maybe that's problem. I don't know, hopefully it sounds like you can hear me now though. Some kind of DirectX overlay bug thing with FCUX. Yeah, I don't know. I don't know what the problem there is, but I thought the bug was working. The ROM was working in Messen and not in FCUX. But when I tested it after the stream last time, I was still on this dual screen setup. And so it's funny how that works. Okay. So let's okay. So previously we brought our graphics in as a compressed RLE, and I had this file here, AA313. Trying to figure out where. So that was actually source file, source folder graphics, Rev3. So now we want to import this instead, this tiled name table. Oh, okay. But there's a couple things that are gonna keep this from working, but let's so trying to think, make this skip over here. Because this is a compressed. And so we have this call to VRAM on RLE, but we want to do something else instead. We want to send it I don't know what the function is. So NESLib so here's the on RLE. Read, write. So VRAM write, we give a pointer to the source data, and then the size. Whereas on RLE, we gave a pointer, same type, but we didn't have to provide the size. It figures out the size for itself. So I think we can call it basically the same way. Yeah, VRAM adder is setting the address, and then this is just writing a chunk of data. So and then size is going to be, oh, this excludes the attribute table data, but our RLE version included it. So this is unsigned int size. That must be a 16-bit int. So that should be the size of a name table. Because there's 2K altogether, 1K per 3C is name table, 30 rows, 960 bytes. and the rest is the attribute table. So the attribute table .960. Yeah, the attribute table is 64 bytes. Yep. 960 3C0. Let's just send a decimal value. So this is, it's not a C file that we're including. It's a inc bin, include binary. Yeah, I don't really expect to set the PP before calling it, which we did. Yeah, so we're moving away from NES screen tool now, and we're going to have to generate these things ourselves. We need to include binary data in our project and a pointer to it. So I gotta figure out how to do that. I think. So I think this is how we do it. Well, it's a segment, so this is an assembly file where they're having the includes for CHR. Oh, here we go. So I think we can do this. Name table data. But it's an assembly file. Pretty sure this is not going to work. Yeah, implicit int. because we well, if I can include it in a assembly file and then bring it over, I don't. So, yeah, I've been Shaku saying. And that's basically what we did. So he's saying name table data, ink bin, that. Oh, well, wait, .h. He's putting an underscore in there. Oh, then have, I'll bring this chat over. So then have unsigned char myRLE data array. Okay. So now we have an unsigned char array. Oh, extern constant, yeah. Yeah, for the underscores important. Okay, so and then I'm assuming these names basically have to match up. Oh, export it. What do you mean by export it? But I got this in the same file. I didn't put it in a different file yet, but it's not. Maybe I don't. Doing something wrong here. But okay, so I don't have an ASM file, but I guess I just need to make one. Because this is actually assembly here. So yeah. Okay, so let's create a new file. nametables.asm. Okay, so in ASM, you include the data. In the header file, you define the extern. Yeah, so here's our assembly file, name table data. This is making a lot more sense now. So then we have to export name table data. And then, but we're not including the thing that I'm not sure about is including assembly file in the C. So I have to do like a begin and end ASM to don't forget to find the segment and assembly file if you want to be in a specific bank, and I'm not quite that far yet, but I'll so for now I think this just is all going to fit in NROM. Okay, so we can have a H file that does all this, or that imports the C. No need to include in C. So I should be able to get by without the H file for now, and then I could put this in an H file, right? So I have the assembly files exporting, but I still need to make the jump from assembly to C. And so, okay. Let's just look back here. So if we say we have an externally defined, yeah, so I'm going to get it working and then we'll move it into a H file. But I don't, so I need to include that I still haven't included it unless you're saying the linker does that all for me, but I can't imagine how it would. I don't have I forget a semicolon. Yeah. In the C file, you want to use the data, just write the extern. Yeah, so I guess maybe the linker finds it for me, but I didn't point it to the assembly file. It can't just find that assembly file on its own though. I need to include it in, maybe if I put this assembly file in the main source folder. I don't know what the make file looks like. So you're saying I don't need to include anything, but the linker needs to have the ASM file that we created. If I'm not giving it that assembly file, then it can't use it. And I don't think it has it. Yeah, so let's see. I think this makefile. So anything that's in the source folder, it'll find. So we put this in the graphics folder. Okay, so maybe I'll find it now. Yeah, and I think that's what I've already got, but what is it complaining about in file line number 97? Pointer type differs. This is, so it's an array. It's just an issue of pointer type. So this is, okay, so this is unsigned char array, and what does, oh, it wants unsigned char pointer. Do I need to do this though? I think so. If I do I need to say the add, but this, it's inherently a pointer because I'm basically giving it index 0, which would be the same thing as saying the address of index 0. The more I think about this stuff, the less interested I become in dealing with cc65. It just, if so much stuff is being done assembly anyway, part of me questions how much value I'm getting from doing things in C. So yeah, pointer types differ in qualifiers. a macro for that nametable adder A and B. And that's what I have here. So it sets the VRAM address here. Yeah, it may save me time, but I'm dealing with these dumb problems, and some of it's just because I don't know what I'm doing, or I'd say all of it is because I don't know what I'm doing. So it doesn't like this call to VRAM write nametable data. This should just be an unsigned char pointer. This one is for address. For write, no, I don't think so though. I already set the address. Let's go look at it. Yeah, but it's saying the size. We'll look at the code. So and this part of it too is learning how, so it's storing X, pop AX, store AX, load yeah. See, and it's just storing the PPU data increment. Yeah, and the data isn't compressed. It's just it's completely uncompressed. This is my data right here. 960 bytes of binary uncompressed. So thanks, he's got it for us. Because yeah, and I have that. So my VRAM adder right here is nametable A. I'm setting, and that's similar to VRAM on RLE, from what I understand. You need address set, and then you can perform an update. Yeah, nametable data and length, and that's what I'm doing. It's the issue is it doesn't like this nametable data as a pointer type. It's saying the pointers differ in qualifiers. Yeah, I mean, even if I didn't have the address set somehow wrong, the problem I'm having is this nametable address pointer, nametable data. The pointer to my data is not. It doesn't. cc65 doesn't like it. So I'm doing something wrong, or let's do this. Let's just create Initially I didn't have the size defined and it still gave me the pointer issue. I'll try it again just to make sure. Yeah, something with my pointer. It doesn't like my pointer type. So I'm just going to make my own dummy version that's not the pal background pal sprite. Oh, let's do this. Right to a block. I forgot the H file. Unsigned char pointer, unsigned int. Line 100 in my file. This is where I'm doing the VRAM right. It doesn't like my name table data. It's saying that the pointer type is wrong. And that's where I'm providing it. Defining it here, and then I'm trying to call it here, and it doesn't like it. So instead of importing, I'm going to try make it simpler, and then so still saying pointer types differ. So constant unsigned char Let's just try a different function. Dang it. I mean, I've been using NESLibs, so I just used it for VRAM on RLE, and I'm just using another function in the same file. So okay, that worked. Oh wait, maybe, but I didn't. Okay, so I called background palette constant char. Oh, that wanted a constant char pointer. It didn't complain about it, even though we sent an unsigned char. Okay. On RLE wants const unsigned char. Since there's no... Yeah. Your extern const, so it doesn't like it. Yeah, but okay, so this works, but I'm just calling the palette background. So now I want to call, that's with my dummy array. I'm not defining it externally. It's defined right here. But when I call VRAM write, using that, it doesn't like it. My dummy name table is constant unsigned char array. VRAM write wants unsigned char array. Is it? Yeah, the constant. So, okay. So then let's do this. Let's make a pointer that it likes. So it wants okay, so now we have an unsigned char pointer, name table data pointer. Does that work? Which line? 39, undefined symbol, dummy name table. Line 39. I defined it right there. Oh, underscore. All right. Did I not? Okay. Incompatible port types, number 39. I know, but so I cast it. Yeah, let's just try casting it. Let's just cast dummy name table into what it wants. So it wants unsigned char pointer. Okay. So that looks like it worked, but that was just my dummy. So now let's try it defined externally. So name table data. Did I miss that? I thought no, it's the same. It's just, okay. So unresolved external name table data referenced in main S. So now it's saying it can't find it. So probably in my makefile is not doing what I think it is, including yeah, so it is looking for name table underscore name table data referenced in main. It's unfound. So we have it. Yeah, we could change the header. We got that figured out. So now my problem is that assembly file is not being included like I thought it was. Okay, so let's I hate makefiles. I'm not sure which one you're. The problem we have now is it can't find the symbol name table data because it can't find that name table's ASM is apparently not being included in the build. And so where is this getting built? Temp. Yeah, Ben Checker's offering up his makefile, and I think he might have sent it to me already. I took a look at it, but I haven't. And it's this mess. I I know I'm going to be writing a lot of assembly. Part of me just wants to ditch it all together. But I don't think I'm going to do it today. I'm going to be a little stubborn at least. See if we can figure this out here. So that or not. It's in the temp folder. So all the O files are in there. All the object files. So main ASM compiler, these I hate these shortcuts. I never know. I can never remember to look them up every time. All right. So we want to assemble main ASM I'm looking at just including it in line, if that works. The compiler allows you to insert assembler statements into the output file. To the output file? I don't know how that's gonna work. Let's try it though. Just underscore oh. Let's try that. I don't think it's going to work. Not exporting. Hey, Nikito, how you doing? Yeah, sudo instruction inkbin not supported. Okay, we gotta figure this out. So did it copy everything over? There's no assembly files in here though. Source CRT0 ASM. I think if we do it on our own, oh gosh, make files, man. So Nikito's asking, so you're done with the sprite palettes and getting into coding? Yeah, to some degree. I'm definitely not done sprites. We've got something working in tiled here. And so now I'm trying to import that. We're gonna want to compress it at some point. I thought this was going to be relatively easy. To import, but I'm still in this project that CPP Chris made, and I really don't understand everything, and that's why I like to start from scratch. Include the path that long or easy to make mistakes. Automatic path makefile will make it easier. Yeah, to some degree, being fancy with being automatic is not my priority right now. I kind of just want it to work. And then make it automatic. I have to do it manually. Yeah. All I ever usually deal with is makefiles, but jumping into a makefile that I don't understand is, I'm definitely not good at makefiles. So we need to assemble nametables.asm and put the output file in to temp, I think, and then the main compiler will take all of those files. So where are the S files? Is that assembly instead of ASM? Yeah, okay, so these are the generated ASM files. So what if Yeah, the linker needs to include the created object file in my target. That's what I'm trying to figure out how to do. And I don't understand these. So the $arrow. $@ is the name of the file being generated. $arrow is the first prerequisite. If you can find a list of all of these special variables in the GNU makefile manual. So I really don't. Yeah, I'm not remembering this stuff either. I'm curious though. The real difference between naming ASM and .s. So how are the library files being compiled? Because there's all kinds of in the NSAM lib. Okay, so yeah, that's what I thought. So here, temp base ASM include config ASM include, yeah. So temp CRT0 depends upon these. So can we just do temp name tables .o main assembly compiler so the input file and then we'll output to temp nametables.o, and then I don't think we need any. So we'll just run, create name tables. Let's try that. Oh, I still have that junk in my main. doesn't look good. Let's make clean. Why is it copying? Oh, I missed some things. I'm gonna check this later. Yeah. Object file is dependent on build directory. Create the output files from the source. And then the flags. Did it create the... Did we build the name tables? Doesn't look like it. Is it copying? I'm not sure what you're talking about there. Nikito. So I added this dependency. Oh, and what Ben Chucker said. Let's do this. Let's do it manually and see if I can. Tool cc65. Okay, so we created name tables. Oh. Yeah. Okay. So I made it, but the makefile didn't make it. So I made this dependency, but that doesn't mean that it's running. The command line, this is console 2, if that's what you're asking about. The command, the terminal that I'm using for my, if you're asking which terminal I'm using, it's called console 2. It's okay. I haven't found a better alternative for Windows that allows tabs. So I wonder if that'll work. Oh, I think it did. The makefile didn't make the object file. I did. So let's see. It's going to be a mess. But I think we did it. It's got the right build time. Nope, not FCUX. Let's change our default to messin. Hey, okay. So we built the ROM. None of our tiles are right because we haven't actually converted in the CHR. So I don't know if everything worked. We at least built it. All right. So let's see. Yeah, and that was expected, but I was gonna look at the PPU. Everything's black. Well, tell me which tile number. Address, name table, 0. Location, tile index. So it's saying everything is 0. Which it doesn't look like it worked. Yeah, but I should at least have the tile data. Let's try this. So this is just a little array. Oh, I only wrote 5. I didn't change that. Let's make sure that okay. Just trying to make sure that we can write binary values. Okay. So that worked. We have in the top left corner, we have tile 0, 1, 2, 3, 4. So let's, I think the problem was just that I forgot to replace this with 960. It only copied over 5 bytes, and the first 5 bytes were all zeros. So, is there a shortcut for... Hey, okay. Our CHR is all messed up because we haven't swapped that over yet. But this looks kind of like our tiled. We need to get our background graphics corrected, but we've got some of this stuff, and some of these actually were in the same spot, I guess. Because here's my tile set that's currently in the build, and here is my tile set. So the ladder's actually in the same place, and some of these bricks are in the same place. And so we did it. Now we got to bring the well, my hack of the makefile, but let's see if we can hack it slightly better. Okay. So there's my ton of echo tests. This is crazy. Dirty. I'm not gonna try to get smarter about make files right now. And I'm not 100% sure that I want to stick with C. I just don't know if I'm up for it. It's gonna like do it for every single file, but it's there. Okay. It's ugly, but it works. All right. So let's fix our we did it Reddit. Let's fix our tile set. Close out mess in here. Well, so the palette data is stored in the attribute tables, and so that's something we still have to do too. But so we have the name tables updated. We need to get the pattern tables, all the tiles, converted, and then we'll get the attribute tables, which tells the NES which palettes to use for which tiles. Yeah. So to do all this, tiles equals the patterns. Yep. GIMP's going to take a minute to load here. So this kind of goes back to the process that established working. I don't remember which stream it was. I think it was 2 streams ago. If this is 6, then that was 4 maybe. So we copied, or actually it was probably earlier than that. It might have been 3, because we created this tile set, but all the palettes wrong. To convert this to NES format, we have to change the indexes. And so my trick for that was just search and replace in the hex editor of this bitmap file. Let's see, color, add a tab, color map. Okay. So how am I turning the tiled stuff into the stuff the NES needs to be given? Well, that's kind of what we just did. We did that last stream, and so tiled takes an import of the tile set that we made in GIMP, and then it exports in multiple different formats. One of the formats is Lua. And so what we did last time is we read in the name table, or the tiled export. Tiled basically generates name table data for us, but it wasn't in a raw binary format. So in Lua, we just took the let's have it hard code here. Anyway, we converted the Lua output from tiled into raw binary data, and then we just now built our ROM using that. So none of that was done in the makefile. It could be put in the makefile, I suppose, but I haven't gotten that fancy yet. So we need to convert this tile set, which right now is just a bitmap. We need to convert it to a bitmap. I'm planning to use NES Screen Tool. It's kind of manual process, but NES Screen Tool can import. Let's save this session. So it can import a bitmap as a tile set, and if we try, oh, did I export this as a bitmap? Oh, I think I did. Well, let's see it. Oh, I got the chat. Scrolled out of view. My bad. Tiled. Oh wait, it's not in tiled, it's in GIMP. That's why. So if we import the Forsaken Valley bitmap, we lose some color data. You can see it's here, but this brick should be 3 different colors, and we lost some because it doesn't know what palettes to make of the bitmap. It doesn't know what to make what. So we need our palette plan. Okay. So plan was let's start with, I think I'm going to start with the green area because the bricks is actually somewhat complicated because it changes between 2 separate palettes depending upon which screen we have visible. So yeah, we lost a color here. So we want to where is my GIMP? Here it is, toolbox. I guess that's what I want. I thought I could. Is it not just a pointer tool? Oh, picker. We can use the picker. Color index 191, 117, and 96. Sometimes this is easier on paper. Okay. So let's look at this. In a hex editor. Forsaken Valley Sky. That's X. Oh. All right, Forsaken Valley Sky, we'll open that with our hex editor. All right. My phone is on Do Not Disturb, but still buzzing. Anyway, 47A is where our data actually starts. 47A here. So I'm going to let's create a copy of this. Yeah, so we're manually editing the hex bitmap files in an editor. It's probably not the way to do it, but shouldn't have to do it that often. And instead of it's going to be a heck of a lot faster than clicking every single color, every pixel that's the color that we want to change. So the green palette, we have so entry 0 is always going to be black, and that should be basically already done for us. Color index 0. Okay, we want to change, so we're going to roughly look like this. If we look at this palette, we wanted dark green 0B, and then we want bright green 19, and then we want, whoops, so 0B, and then we want this one to be 19, and then we want the tan to be 37 or 38, something like that. Doesn't really matter, this will define elsewhere. 38 might look better, but so 0 is going to be black, which is the background. 1 is going to be our darkest. So in general, our entry 1 is going to go from darkest to lightest. So which color do we want to change to what? So we can, he's asking if black is 0 black. Well, we can change, you can change the background color on the NES. You can make it any color you want. Like Super Mario Brothers 1, the background is one of these light blue colors. You technically have 3 layers on the NES. You have whatever color is the background. And that's actually, that color is the same for every single palette. So you get to pick that once, and then every palette has that as the color. And then you have the background layer, which is what we're working on now, and then you have the sprite layer. So you get to choose one color for the background, and every single palette gets that. It's transparent background, however you want to think about it. But yeah, you've got 3 workable colors plus background, and every single palette has that same background color. And then sprites have transparent and then 3 colors. So it's similar, but it's truly a transparent, because you'd see the background that's behind there. Okay. So the darkest green is index number 96. And we want to change that to index 1. So in this Forsaken Valley binary file, we're going to search for an integer number, a byte, all directions, 96, which is hex 60. Yep. And every place we hit that, we want to replace it with a 1. So let's do search and replace. Search for 96 and replace with 1. All directions. Replace all. 520 occurrences. Okay. So let's save this as so you're already doing it, or you have a plan to encode which palette each tile uses, or mailing to it. So the plan is tiled has attribute, you can do custom properties. And so we can look at a tile, and I created this custom property palette. And then that will export from tiled, and then we should be able to generate our attribute table data similar to how we generated the binary data for the background for the name tables, but it's going to be a little trickier because attribute table is which palette for a group of 4. So that'll be the next step after we get our background converted. So I'll try this. Hey, we did it. So that worked. Everything that was dark green got converted. And this is where this is the same color green over here. I don't know if I forget. We're going to run into these. We're going to run into this issue, but I wonder if, because we can use this color map. Where'd my NES? I thought I had an NES. I don't know. Okay, can we just pick a color to change this? So maybe it would. I don't know this. Let's try it though. Okay, so we want so that's gonna be green. The next palette's always gonna be gray. So that one needs to be black. And we want, these aren't going to be accurate, but dark brown, dark gray, and then light gray. This one, black, and then this is our dirt palette. So medium. There's a brown, light brown, so it's supposed to, I don't have a whole lot of browns to pick from. Okay, so it's gonna be, yeah, it's gonna make those four. This is gonna be pretty. and then black, and then we got a cyan palette. This one needs to be white. So I think might get confusing, but we could export this bitmap. Some of these were already used. So we did change the color map, and that should be part of the header. Still 47A. 47A. So we can select all of the header. Paste it into here. All of the and then save it. And so there we changed, so now it's not red anymore. Now it's actually closer to the green that we want. Because I basically just changed the bitmap data, or the color map data in the bitmap file. Okay, so we also need to change. So this color index was 96, and we shouldn't have any more 96s. We should have those all changed. Color, so 117. So Control R. $117. We want to replace with 2. $428 of those. Okay, and then the lightest, index 191, we want to replace with 3. Okay. So save this. delete all of this. Copy, paste the header. That's all right. Try copy, delete. There's the header data. There's the bitmap data. And it's actually right, but those greens look really similar inside Paint anyway. So if we import bitmap as a tile set, might not have. Does not appear to have worked, but it might have been because we had other stuff. We have too many colors in here, so let's just drudge on here and see if we convert everything, if NES Screen Tool will like it. Okay. Let's do the dirt. This is supposed to be the darkest. So it's index number 11. Then index 29 and index 191. And those are going to become that's an interesting, we could change it. Oh, we don't have a way to do that block. So we're going to change, so 11 is going to go to 9, 29 is going to go to 10, and 191 is going to go to 11. So 11, nine. Oh, that's a lot. 29 is going to go to 10. And 191 is going to go to 11. Can't find 191. Why not? Find 191 integer. Can't find it. Did we already? I think we already did it. Because I think, yeah, that's why. The little spikies were also color index 191. So that was already done. And that's kind of why we have to be careful. And that's okay. It's just, it needs our arrangement of dark to light should be fine. The only time that's going to become a problem is if this green we want to be somebody else in the trees. We'll figure it out, but that was okay. So what's next? We can go ahead and do the sky. So the mountains, sorry. So the cyan, the mountains, the darkest color is index number 80. And so that'll become 13. And then the blue is 225. That'll become 14. And then white is 255. And that'll become 15. Okay, so 80, 13. And this is kind of manual, but it's not that bad. I don't think we're going to have to do it a ton. It's just if I accidentally make a mistake and change a bunch of colors to what I don't want them to. Okay, save. There we go. So the fence is still not good. These bricks in background, and that's where it's kind of tricky. Let's see. What did we decide? Yeah, so in the dungeon screens, we don't really need the third color. It can be brown for the broken bricks, like this one down here. But we need the medium gray and the light gray. But other areas are in the dungeon. Oh, we also have that plank thing. One way to do that is to, okay. Let's do the bricks. So I think we can just change the brown to the one we want, the medium gray. Okay. Oh, see, look at this. But oh, it's okay though, because it was the same dark brown. So that one already got taken care of for us. Dark brown's already converted. So The bricks, the dark is already done. The gray is 164. For the dark gray, and the light gray is 7. So 164 is, excuse me. All right, so that one we want it to be 5, but it shouldn't really matter. So 164 is going to become 6, and 7 is going to become, what do you know, 7 should already be done. 164. See, and that's a collision that could cause problems. As if it's something's already using what are these numbers? 49. Oh, the fence stuff. We still have some. So this, so how are we going to do this? The fence is what we're trying to figure out here. The whoops. So when there's vines growing on the fence, that chunk has to use the green palette. It won't have the gray or the tan. It's going to have the 2 shades of green. So in that case, really it would require massaging the art. The color we want it. So these other fence pieces, we're going to use the same palette as the bricks. So we'd have a dark gray and a light gray. So let's just go ahead and change that. Okay, so yeah, 164. So that's supposed to be the light gray. Oh, but we already converted that one. And then this, we'll make it dark gray, but it's this green. So 80. Let's see, what's 80 supposed to be? Oh, we should have already done 80. We did it with the sky. That's gonna be messed up. What are these 49s? Oh, but that's 49 hex. $73? What is 73? Where's that? Oh, it's this background, the dark gray. We want that to be this index right here. So that's decimal 73. Yeah, 73. We want that to be this one, 6. So 73 gets changed to 6. Okay. What's 60? 96. There's some extra green. Was it this? It's what's that? 96. I think we should find it if we open it in bitmap or in paint. I think we can find it this way. So if we change color 96, oh, that's supposed to be our, maybe we didn't save our, that was our very first change we made. It's supposed to be changed to 1. So let's change that color. $60, 1, replace all. Can't find 60. Oh, because it's 96. Oh, well, and that's probably why. NES screen tool didn't work when we tested that. Okay. Import bitmap as a tile set. This one. Ooh. I think it worked. So the green vines are like that. The next index was supposed to be our, we changed things around to make it brown. So this is our index for the bricks and stuff, our palette. We made this one. We made the last one. So there's our sky and our mountains. Oh, does GIMP not have search and replace feature? Colors map exchange. Ah. The only thing I wonder, I have to test it out, is I just want to make sure that that isn't just changing the, keeping the same index of the color map and changing the color. I want to actually change the index, not the color. So I don't know how that, one way to do that, or what that tool's, that search and replace is doing, is just changing the color that index is. And if that's how it does it, then it's not going to work. But maybe I have to go check it though, because it might do exactly what we want. And then this last palette is supposed to be what we use for the planks. Or not the last. Is it the last one? What are we? The last one's supposed to be cyan. This one's supposed to be the planks, and also the dirt. Anyway, so there's our dirt. Okay, so I think we converted it. Let's export. Patterns, save CHR. We still want to save it as a, where do we want to put this? I guess NES screen tool. So that's now. We need to change our import of the tile data. Trying to remember where that is done. It might be I don't remember. Oh, I think. Here it is. So it just automatically includes graphics tiles CHR. So if we copy over, let's just change that. Graphics Forsaken Valley CHR. But we gotta copy it. Oops. Is it in? I think it's there. Okay. It took a while, but it's a bad hack. But moment of truth. Oh, yeah. Okay. We're close. Might not look like it. So let's look at tiled. Now our color data is all wrong. Oh, it's off by 1. Because the ladder we drew was supposed to be these two tiles, but it's drawing it as these two. So I wonder if the export data from tiled is indexed by 1 instead of 0. Let's see here. Tile ID 0. Tile ID 0. Tile ID 255. Maybe my Lua conversion's messed up somehow. Oh, the bad hack thing is my makefile hack that every single time it builds a file, I build the, whoops. I build the name tables ASM. Yeah, they are off by 1. Let's look at our let's look at the binary data first. So these first two tiles are supposed to be $241, $242. Yeah, I mean, it's bad because I know just enough about makefiles to get myself in trouble. Yeah, I mean, it's doing it like 8 times. And it's overly but anyway, it gets the job done for now. I'm not sure I want to stick with this as a starting point anyway, so I'm not going to invest too much time with it. Okay. So what does this is our binary data. So F2 and F3 supposed to be tile 241 and 243. Is that hex 241? Yeah, so that's off by 1. So it's definitely wrong, but this is their straight up import. Let's look at the Forsaken Valley. What do we export this to? Test 2, was it? Yeah, test 2. So split this with test2.lua. Look at that, data 242. So I suppose because it's exporting to Lua, it knows that Lua is 0 indexed, and so, or 1 indexed, and so it does that conversion for you. That's dumb. Okay. Yeah. I do love Lua. But the 1 indexed sometimes it's nice, but then you get in that habit and then you get burned when you go out of Lua. All right, so we gotta subtract 1 in this conversion. So file right. Here's where so for byte in tiled layers data, write this. Okay. Yeah, you just have to be cognizant of it being 1 indexed. Yeah. So let's just make a note here. Apparently tiled converts the tile numbers to 1 indexed for Lua friendliness. So let's just subtract 1. Yeah. All right. I don't know if that'll if that'll sense the change. Yeah. Part of me wants to ditch this cc65 just because of how dang slow it is. I don't understand why it's so dang slow. All right. We fix it. Oh, we didn't. Okay, I made a mistake. Well, we didn't complete the process. So my conversion worked, but we didn't so now the binary file is done, but we actually want to copy this. $11.58. Oh, last week. Replace. Hey, there we go. So now, none of the pallets are right, of course. Expected that. But we got our CHR data imported. And the heads up display is all wrong because we're actually going to do a bank switch on the pattern tables to give us more tiles. So for now, that's just going to look wrong. But, oh, and there's scroll works in my demo here, but yeah. We got the tiles converted in. So the thing that's going to get now, the next step is handling the attribute table data. Maybe we can start on that. I don't know how far we're going to get. I'm gonna have to take a break, but so I added a custom property palette. And so I put all these bricks as palette 0, but really that's not true. These are we want to be palette number 1. is a property in the tile set or in the map tiles? It's in the tile set, so in tiled, you can edit the tile set. If you recall correctly, I want the bricks to use different palettes and different map tiles. And yes, I'm not sure. That's gonna get kind of messy, I think. And so I may just have a different tile set. I think it'll be okay because if I'm just thinking about, I'll have to have a different tile set. Yeah, so when we're drawing, the whole idea was, and I may change my mind, but, well, I can't really change my mind because so for one issue is with these bricks here, they have to be the same palette as these boards up here, and that ends up making us recent files. This one, you can see it here. These bricks, sometimes they use this palette, the gray. Sometimes they use this palette. They have to share with the boards. And then the idea was in these dungeon screens we can have 3 different grays by having the background drywall 1 gray. Yeah, when you're saying we have the same style set twice, we don't have room. But if I think it'll be okay. We're going to generate our own attribute table data, and so one way to do that would just be, especially for these, we can say, well, what's the top left tile? We're going to use whatever palette we want that one to be. And so these other tiles just get set based on what that top left one was. So these bricks just don't even really have a say-so. But when it is just the brick as the top left, then it would use the palette for the grays. But one of the ideas to get the extra gray was in these dungeon screens, we can have 1 gray for the background, have 2 grays because the ladder's using the same, but then 2 different grays for these bricks. And so we have more than 2 grays because these bricks use a different palette. And then you can see the clash right here. But when we scroll this outside area, we only have 1 palette with gray in it because we need a dirt palette. So part of me, I don't know, that might be too much hassle for an extra gray. But reserve the right to change my mind. And maybe to start, we'll just assume that we're not doing that, and then we can add that feature in perhaps if it, I'm not even sure it's going to look good or be able to tell the difference. One thing I don't know if I changed over was these I guess it did. Little well. I guess that was dark. Anyway, some of these things are probably not right, but we can go in and massage them just by tweaking it and setting some flag color in GIMP. But I don't know, I'm probably gonna call it a night. We met our goal of we converted our background tile set into the NES format manually with the process we created last time or a few times ago, and we figured out a hacky method of importing the name table data in binary form. We still are going to want to compress that. We still have to create our attribute table data. But next time we'll work on creating the attribute table data. I don't know if I'm going to bother trying to compress things right now. I need to decide if I'm sticking with C or not. Yeah, so thanks for tuning in, everybody, and have a good rest of your week. And I got a question. Is the heads-up display here doing the bank switching? We haven't done it yet, but here this ROM was the simpler one because it only used a few tiles. So we added a bunch more tiles and then we lost it. So we'll have to get that bank switch in later, and yeah, so still lots of things to do, and of course, but y'all have a good night, and we'll catch you next time.